Hello students, welcome to JE English by Unacademy, India's largest and leading test preparation platform. Guys, today we are on JE English where we are going to deliver content exclusively in English, be it you're preparing for any competitive exams, or be it you're preparing for IIT JE, or be it you want to learn something from the basics until the depth of physics, chemistry or math. Guys, we are best in class educators on this channel. Do subscribe to our channel. The educators have previously cleared IITs and have a enormous amount of coaching experience and good amount of qualifications. They know what you need to get from the basics until the depth. Not only that, guys, they know what to do to get through the exams. And guys, today we are going to explore kinematics. So what is kinematics? We know kinematics can be used for creating games, graphic based games, like interactive games, or maybe attractive mobile applications, navigation based or map based applications. But what is kinematics? Kinematics is the branch of physics or science or mechanics that deals with the study of motion. Okay, kinematics exclusively talks about motion and motion only. Okay, it's not about stationary bodies. Awesome guys, do subscribe to our channel. Click on the bell notifications to get timely updates. And guys, a little bit about myself. I am Muralidharan. I am an IITian myself. And I have completed my MS in Electrical Engineering from University of Colorado Boulder. I have 4+ years of experience preparing students for IIT and other competitive exams. And I have filed 18+ patent applications in India, US and Canada that involves physics and computational math. And guys, today I am here to teach you physics, guys. I want to make sure you get everything of physics. We will tear it apart. And you know what? We have to explore every bits and pieces of physics. And guys, I'll make sure you get passionate about physics and you get better than me. So now guys, Unacademy and myself have something interesting for you. That's our Unacademy learning app. You can go to Play Store or App Store and download our app and get special live classes from our top-notch educators. And guys, if you're preparing for, exams, or if you're serious about learning about some aptitude exams, you can go on to our, subscription platform. And if you're specifically looking for, IIT JE program, and you can go for choosing this IIT JE program on our app and get the subscription to prepare for your exams. We have structured learning, we have live quizzes, we have everything that you need for getting through the exams. And guys, it's not just about, how well you learn the concepts. Exams are also about timing. So it is important that, I recommend you attend some or the other kind of test series. And guys, if you're looking for some coupon, you can make use of my coupon Murli Live. And if you're in 9th, 10th or 11th class, I would recommend that you go for a 24-month subscription over any other subscription because it's a 24-month long journey. And guys, go for IIT JE. I would recommend go for IIT JE. The kind of education, the kind of quality you would get in IITs is unmatchable. Trust me guys, I'm graduated from, US, and I know the quality difference between IITs and, any other institutions. And if you're in lockdown or something, do go for 1 to 3 month subscription, and it's hardly 5,000 per month. And we have collection of around 250 study materials in physics alone, and we also have study material from DC Pandey. And not only that, we have structured learning, so that you can quickly run through all your this necessary materials. Alright guys, this is all about exam, and you know what? How do I get on Unacademy, and what is kinematics? Who am I? But why are we here today? For kinematics. So, but before we start about kinematics, there is something, we need to talk about some unit that is like the fundamental of kinematics. If you understand this unit, we'll understand easily the kinematics. So the first one we may want to talk about in any, whenever we are starting with kinematics is, distance and displacement. So what is the difference between distance and displacement? So you see this bug over here. See, this bug is traveling, in some random path. I mean, you can't even trace that path. But this random path, right, this total path, that is distance. So in this entire, journey, this bug is completing this entire path. So this total path is journey. This total path is the distance. You have to add that little pieces and find out the distance. Whereas in displacement, you do not have that as well. It's just the distance or, the length between the initial and the final path. or rather I should say that, final and initial points. And the thing is, it has a direction fixed to it, attached to it, which differentiates it from, distance a lot. Because it becomes like a vector quantity, displacement is a vector quantity, whereas distance is a scalar quantity. And remember guys, distance is the total length covered in this path. I'm being specific and critical about it because you need to keep this in mind. And displacement is not necessary. I mean, it's the shortest path between 2 points, but you need not say that, it is the shortest distance or something. Displacement is displacement. You need to keep it in the mind. You need to understand displacement as a vectorial quantity, not as a, quantity that is there. It's a physical quantity. It has a major play in physics, especially when we are going to, as and when proceed into dynamics and everything. Displacement is different from distance a lot. A lot means a lot. And guys, remember that to find displacement between 2 points, let's say in this case A and B, okay, this bug is starting at A, right? Let me just use another color so that it's more clear. So let's say this bug is starting at A and going until B. Then what you would do to find out displacement is, you would subtract the coordinates of B from A. Okay. And the thing is, why am I saying this? This will give the direction towards which you have to travel. It has to tell the direction, right? What is the direction? It will tell you the direction towards which you have to travel, towards the final point. So if you do final point minus initial point, you will get it. And what now guys? What now? We have been talking about distance and displacement, and we know, there is something known as cardinal axis. But there is some convention for the cardinal axis that we need to remember all the time. So when we are talking about, cardinal axis, there is east, north, west and south. And in this, east is along plus x-axis. So you can give it, like plus I cap, convention, or plus I cap. So if there is some quantity that has been given in east, then you would represent it using I cap. For an example, a person is traveling towards, this person is running towards, east direction. Then you would add an I cap to its velocity. And let's say a person is, has traveled 30 meters towards east. Then you would say 30 I cap meters. So that makes our life easy. I cap, J cap is the vectorial representation that makes our life easy, that makes physics easy. And similarly for north, you will use J cap. And for south, it will be minus J cap. And for the west, it will be opposite to that of east. That would be minus I cap. Okay. West would be minus I cap. Okay guys. Now we have been talking about cardinal axis. Now there is something very important that we need to understand. The entire physics, the most of the things that we are going to explore in physics, be it in your exams or be it for conceptual sake, it is very important to understand the concept of slope. Why? Slope will help you resolve things, into vectorial components. Not only that, slope will give you a lot of information about what is happening around you. So for an example, let's assume this is the bug that we saw in the initial, the presentation slide or lecture, and this is some sort of target, the final point it wants to get to. So this is the direction it has to travel towards, isn't it? So in this case, let's say now this line has started rotating, which means slope has started rotating. So slope is generally the angle between, the line and x-axis. They'll generally slope is expressed in terms of theta, and it is the angle between x-axis and a line. If it passes through origin, well and good. Even if it doesn't pass through origin, like in this case, still the slope is going to be that. Now, slope is telling you something very important, right, for vectors. So that's the direction. So slope is talking about direction. Now, when I'm talking about the slope, it is talking about direction. I know the direction. So even if someone tells me, this is the distance I have to travel. Okay. Someone tells me I have to travel 5 units. And that too, like they have told me, it's along plus x and plus y of this, coordinate axis or some other space. So, and they have told me there is this slope theta on which you have to travel to get to that place, or you have to travel along theta. Then it tells me the exact direction. I do not need, x x-axis component and y-axis component to understand it. So let's assume now this bug is over here and this line has started rotating. So direction is changing. Now the bug has to travel in very different directions to get to that, sort of, that endpoint. It has to travel in sort of very different directions. Might be like a mad circular direction to get there. So slope is telling you direction. And this bug may not be, very intuitive or may not be practically connectable. So we will have a look at something where we can connect much and understand using, just numerical examples. For an example, let's say there is a slope or line, or let's call it inclination for practical purposes. Inclination, like how you travel on a hill or something, and it's of 30 degrees. There is a man running on it, okay? And this person has to run more harder than you would run on a plane surface, but less harder than a larger degree. So in a way, inclination is also, affecting other parameters in this game. And similarly, let's say now it is 60 degrees. Now it is 60 degrees. Just a moment, guys. Now it is 60 degrees. Then this person has to travel more harder. He has to run on, like a larger slope, which is going to be like, very tough. Like especially if it's a 60 degrees hill, it's going to, exhaust a lot of energy. It requires a lot of work done compared to rest of the, like a lower angle where, you don't have to do a work against gravity. So this inclination is sort of giving you not just the direction, but also telling you about something very significant about work done, how the forces are going to act on it, and how the kinematic motion is going to get affected in this play. And similarly, let's say the person now has to travel at 90 degrees. Okay, at 90 degrees, which is going to be impossible. This is like, you have to be a Spider-Man to climb up this sort of 90 degrees or something like a spider itself to do that. But the essence is slope gives you direction and tells you a lot about any sort of kinematic motion, or even in that case, like it gives you a lot of information. You just need slope. You may not need, the exact x and y axis coordinates. You need slope and you need to know the magnitude. Many times you'll be able to make out the direction. Slope tells you about direction. Slope specifically talks about direction. Now the thing is, you can resolve the slope into x and y components. So we are going to do some math to understand the slope. Like people don't understand theta because theta is something that we don't use. It's like this thing that, that's weird to us. Like sometimes we do understand theta, but theta is still not something that we see practically. We see 1, 2, 3, 4s, or even sometimes, like 10 hundreds, or whatever, like it is like some numbers. Mostly not negative numbers, but positive numbers. But numbers is what we are more used to. So we are trying to make use of some quantity to represent it in terms of numbers. And we'll see how we'll do that. So let's say now this person is running on this, on the slope, and it's at an angle theta. Now this person covered a distance x1 because like he has approached this point R. That's our assumption that this person has traveled from origin and he has reached this, position R, which is denoted by this position R cap. And the coordinates are x1, y1. Now the distance he has traveled along y-axis is y1, which is, x1 units away from y-axis. And similarly, the distance he has traveled along x-axis is x1, which is y1 units away from x-axis. Okay. Now the thing is, he has covered this distance. We know, we just know, let's say theta and x1, y1. Then how do we, we know just the theta and r, the position. We are just given the position, vector, not really this coordinate like what you're seeing over here. Just forget that this thing exists. Now, how do I express this? It's a vector. I can find out the magnitude. I have the angle theta. Let's say then what does that mean? So when I'm talking about traveling along some theta, it is same as traveling parallelly along y and x axis. So let's say I've reached this position R. That means in some time, it is same as, if I go up this path like this along y axis, then run along this path along x axis and reach this point. But the thing is, this is the shortest distance that can be taken to reach this point. I mean the shortest distance, I mean by displacement. I mean by shortest distance, it is the displacement. And similarly, I can run along y-axis and x-axis and reach that point as well. But the thing is, where what I'm trying to explain here is, you need to understand that it is as if, just imagine that it is as if you're traveling parallel along x and y axis, but you're not really doing it. But imagine that you're traveling along, x and y and x axis. That's the speciality of, understanding displacement, and it tells you the shortest path. So why am I saying this? That means I can resolve the components. So to resolve the components, I'll make use of theta. So now I know the slope. I know that, that the y1 is going to be r sine theta, because this is theta, which means this is the x component is r cos theta, which is the easiest one, which is like, just adjacent to it. Cos theta is adjacent to it, and this is r sine theta, magnitude of r sine theta. So this is just like solving the triangle problem to express in terms of tan theta. We are more used to express the slope in terms of tan theta. If someone is talking exclusively not about theta and just stating slope, they are probably talking about tan theta. Tan theta is what is the slope is in general terms, because tan theta is directly proportional to theta. The value of tan theta until some limit is directly proportional to theta. And now the beauty of tan theta is, it is nothing but ratio of y by x. It is the ratio of y by x. Just like I'm saying sine theta by cos theta, which is nothing but y component by x component, right? We just resolved it. So it was y component and then it was x component. So it tells me the slope. You understood it very well. But there is, a little bit drawback of using tan theta as the slope. Okay. In general, I mean, tan theta is fine if we are dealing, just in plus x and plus y, and just there is only one thing, only one direction. But when we are talking about vectors, we are talking about direction. So direction is very important, and you'll see like how it is entirely changing the thing. So let's say now it is 180 plus theta. Okay. You remember tan of 180 plus theta is equal to tan theta. There isn't going to be any difference. If I give you two values like 45 degrees and you add 180 plus 45 degrees and do the math, you will get tan theta, because simply it is going to be y1 minus y1 by minus x1, which is same as y1 by x1. So when I am going to give you both the values have both 180 plus theta and tan theta is going to have the same values. But specifically see in this case, this person is traveling in the down the slope direction, is traveling downwards, which means like, let's say I'm running, on a hill and I'm running up the hill. I have to do a lot of efforts. You must have realized that you must have gone for hiking, or you must have, walked up the hill. You're doing a lot of work. But when you're coming down the hill, there is nothing you're putting in. The efforts are very minimal. Gravity is just driving you down. Like, all you need to do is you need to balance yourself and, to stay calm. And the difference is this, guys, like when we are using tan theta, we are not actually getting the exact expression of the slope, because 180 plus theta is something that you can intuitively think, in your mind that it is down the slope, whereas theta is something that you can think it is, up the slope. You have to travel up the hill. But 180 plus theta is driving you downwards. It is driving you on the down slope. Now the thing is, we'll just do a calculation, arithmetics around it, and that is what is done over here, which says that this is equal. Okay, this thing, guys, like 180 plus theta is equal to tan theta. That's a shorter way of doing it. I just solve the triangle problem. Now the thing is there some other way where I can accurately, or let's say like precisely represent this slope components, or any sort of like any vectorial components? Of course, guys, there is something known as, resolving something known as I cap and j cap, which we can use in it. And we have to resolve in terms of vectors so that we have the explicit direction, because tan theta does not talk about direction. You see in this case, right? We have just talked about this case. 180 plus theta is equal to tan theta, tan of 180 plus theta. Whereas this person is running up the slope and this person is running down the slope. So there is a lot of difference. There's a huge difference, right? There's a huge difference when we are talking about physics, physical world. We haven't entered the gravity yet, but think once we have entered the gravity, this is absurd. This is not giving us any information. So you need to be cautious about this fact that, when we are talking about physics, slope matters a lot. And slope tells us the direction, in fact, in which we have to travel. And if two slopes, which is up the slope and down the slope, are equal to some mathematical manipulation, that does not make sense, because they have very different meanings when you're going to calculate work done or something like that. But there is some other accurate way or precise way of representing things using the same mathematics, or let's call it physics for better understanding. And also it's physics. Vector math is very much important for physics, and vector math was also developed mostly by physicists who have developed all this theory. In fact, differential mathematics was developed by Newton, I guess. And this person has laid out the entire foundation for differential calculus. And he's the most renowned physicist. So now the thing is, we are going to solve in terms of vectors to, one, it makes our life easy. The second thing is not just it makes our life easy, it exactly tells us about the direction which tan theta would not give us. Tan theta or tan phi, whatever you call it, would not give us. First of all, to resolve it, let's say I just have, just the same, position vector r, which is denoting the position of r. Then I would do the typical thing, solve the triangle problem to know what is x and to know what is y. And now I know what is x, the magnitude of x, but I also know something known as I cap, j cap. And I can use that to represent vectors. So, this concept, I know, but still I'm just iterating it. See, plus I cap is not equal to minus I cap, since they have different directions. Two vectors cannot have same directions. They are different vectors. Plus I cap and minus I cap are different vectors. They have two different directions. Plus I cap is the unit vector along x-axis and like the positive x-axis, and minus I cap is along negative x-axis. And similarly, j cap is unit vector along y-axis, and minus j cap is unit vector along minus y-axis. And again, j cap and minus j cap are different. You need to keep this point in mind. If someone is asking you whether I cap and minus I cap are the same thing, isn't it? They are just unit vectors. They have unit magnitude. And guys, they're just two represent vectors. You have just added a minus sign to it. Then you have to say no. The entire concept of vector is about direction. So minus I cap and I cap are not the same thing. And now the thing is, we understood, this is a unit vector, this is sort of the unit, just not just just about having this unit magnitude, but it is sort of, a standardized way of representing vectors. And this actually only helps us represent a vector, else there isn't, very convenient way of doing it. I mean, you can do it using polar coordinates or something, but still, again, there is unit vectors, they are also unit vectors. But the thing is, they are like a standardized unit for representing vectors. So we'll do the same thing. We just solve the triangle problem. We just saw even this earlier, like if we have a position vector, then x1 would be magnitude of r cos theta, and y1 would be magnitude of r sin theta. Now, what I have to do? Simply add I cap and j cap. I know the magnitude, I know the direction. I'll just add an I cap and j cap to it. I'll attach an I cap and j cap to the x1 and y1. And there you go. You get the r. Now this r is a more precise way of representing anything and even to find out the slope. This exactly tells me on which quadrant of the x and y axis this person is running. Okay, even though it is like running parallelly along y axis and x axis, I still do know it's running up the slope. Why? Let's do it for even the negative direction. So let's say this person is running along negative direction. I'm going to give, even though I know the magnitude is r cos theta, magnitude of r cos theta, and r sin theta for rx and ry, I'm going to give it a negative sign, isn't it? I'm going to give it a negative sign. It's minus I cap, and the next one is minus j cap. And now this sign explicitly tells me that this position of this particular point is not along the upslope with respect to origin. Okay, whereas tan theta was giving me a hint that okay, this is also in the same direction because the values are same. But whereas Now, when we are representing terms of vector, we know clearly that this thing is not an upslope thing, it's a downslope thing, because y coordinate is moving in the negative y direction. So it's a y slope thing. So it clearly talks about direction. And you can also find out, if you're interested, you can find out tan theta, or if given tan theta, you can find out the magnitude of rx and ry. Let's say I've been just given, like the r position vector, and you want to, derive this using tan theta, then you can do it. Or if you're given, some two known values, then you can use this tan theta to derive it. Or if someone asks you about tan theta, then you will take the, ry, exact value of ry. Now what you'll do is you'll take this I cap and j cap apart. And now we are talking about angles. We will take the exact value of ry and divide it by rx. And then you will give out the value of tan theta. Or you will find out the value of tan theta. It's really that simple. And guys, do remember, when it comes to physics, if someone asks you whether traveling on like tan theta, this much is given, or let's say theta is equal to this much, and then 180 plus theta is equal to this much, do you think they are the same thing? In physics, no. They are not the same thing. Practically think about it, it is no. You have to put yourself in the shoes of whatever concepts I'm teaching. You have to imagine yourself in that concepts. And guys, you have enormous things to achieve from just, imagining these things. Because it's more about practical applications. It's more about the practical thoughts. More about, how do you apply it in real life. Even we take this vector math and apply it in real life. We take anything that comes to our, like in terms of physics, and we apply to our real life. You need to get this fact. You need to get this fact why we are calling this specifically physics. We are calling it, like the study of nature, study of order of nature. We're not calling it, like the mathematical representation of something, or something where, it's a quantitative thing or something. Quantitative representation or a mathematical expressions are part of physics. But physics is about practically perceiving things. And kinematics is very much relatable to life, guys. Like, traveling up the hill, or, all this riverboat problem, and maybe, like the car you're traveling in. So that all gives you the intuition of what we are talking about. Kinematics is very much relatable to real life, and it's very easy, guys. Kinematics is the easiest scoring topic. You have to understand it. And the thing is, don't memorize it, guys. Try to understand the concepts, grasp the concepts. When at all, there is no other option, you have to memorize it. But don't memorize it as such. Try to, remember the concepts. Try to understand it with the real life. Like, try to, correlate things, and that would make your life super easy. Super easy means super easy. So now we'll solve an interesting problem. A person was running up the hill with constant pace, which means he was running with some constant, like a speed or velocity, which did not, exclusively say what it is doing. And the distance of the person in the plus x axis and plus y axis was found to be 4 units and 3 units. So now the thing is, this little person over here was traveling up the hill. Okay, let's assume we reach some point over here, and they are saying, along x-axis it is 4 units, and along y-axis it's 3 units. Then find the inclination of the hill and the distance covered by the person from the start point. Okay, let's assume we started down the hill at some point. In this case, it does not matter. They are just told, the person has covered a distance of 4 units and 3 units. But let's say, okay, it was also given the start position is 0,0. And now what they are asking is the inclination of the hill. The inclination of the hill, and what about the distance that he has covered? I think now, like the distance you have covered is very easy. It's 4 squared plus 3 squared, which is 5 units. Okay. And the options given are 37 degrees, 5 units, 53 degrees, 5 units, 37 degrees, 7 units, and 53 degrees, 7 units. 7 units is given to confuse many people, where, they are going to say, like you're just going to add 4 and 3 and immediately go for this option. That it is just given to confuse you guys. So you need to, like, eliminate that option right away. And there are two options, which is 37 degrees and 53 degrees. And I guess, it's a new thing actually. Like when we, started our education, we didn't have this like 3 by 4, 4 by 3, tan theta wasn't very common. But it's sort of a whole number compared to sine 30, sine 60 and things like that. So if you do ry by rx, that's how you find out tan theta, isn't it? The slope. Or then you find out theta. Now it's ry is equal to 3, rx is equal to 4. I know that he has traveled along plus x axis 4 units and along plus y axis 3 units. Plus y axis 3 units. And now we have to divide ry by rx to find out tan theta, and from tan theta, or be it even cos theta or sin theta, you can take any theta that you want once you have calculated the distance. This is 3 units and this is 4 units, it is 5 units. If you feel that tan theta is not accurately giving you the representation, then you can do it the other way around. But don't worry guys, we will understand how to make use of this tan theta. We'll all write it in terms of whenever required in terms of vectors to do the problems, so that it becomes very easy. Now the thing is, I know like tan theta is equal to 3 by 4, which is nothing but 37 degrees. I know guys, I too don't remember this, but there is an easy way to remember this. Tan 3 by 4 is equal to tan theta is equal to 34 degrees. How do we remember this? So, see, this 3 by 4 and 4 by 3 is a new thing in trigonometry that has come up in recent tables. Until some time, we used to read about 30 degrees, 60 degrees and 90 degrees. 0 degrees, 30 degrees, 45 degrees. Again, it moves by another 15 degrees. That would be like, 60 degrees. And again, it's a 90 degrees. Sometimes even you learn about 75 degrees. But this 37 degrees is a new one. But this 37 degrees is more convenient than anything. It looks very easy. Sine 30 is going to look, like 1 by 2, which is fine. When it goes to 60, it's like root 3 by 2. This looks complicated. Root 3, you can't, calculate it in your mind unless you remember it. But whereas tan theta, when it's 3 by 4, theta is equal to 37 degrees is, very easy to remember. So this 3, 4, 5 is something that you have to remember. And then you have to work around this 3, 4, 5 to get the results. Okay. So this is how we have calculated distance in this case. Just, okay, what we have done over here is we have taken cos theta and then calculate the distance. Okay. Now, how do we remember the trigonometric values? Play around 3, 4, 5. One rule, that is, as and when theta keeps increasing, the value of sin theta increases between 0 to 90 degrees. And similarly for tan theta, when, as and when the theta's value keeps increasing, the value of sin theta will keep increasing, and cos theta works the other way around. As and when the theta goes up, the value of cos theta comes down. So what you will do is play around 3, 4, 5, and like tan theta should have something like 3 and 4. You have to play with 3 and 4. Whereas the 5 hypotenuse, the larger value should come in the denominator of sin theta and cos theta. They are going to have common denominator. So when we are talking about that, so what should be sin 37 degrees? The least possible value that you can extract among all of these things, that would be 3 by 5. And similarly for cos theta, if this is 3 by 5, cos theta is easy to remember, 4 by 5. And now we are going to do the other way around for 53 degrees. Once I know cos 37 degrees is 4 by 5, I also know that cos 53 degrees is 3 by 5. Because cos 53 is nothing but 90 minus 37. Isn't it? And similarly, sin 53 is nothing but 4 by 5. And tan 37 degrees is 3 by 4 because cos theta and sin theta, that this cos 37 and sin 37. And tan 53 is 4 by 3, we know sin 53 and cos 53. So it's really as simple as that. So remember this trigonometric values. Nowadays you are getting this kind of trigonometric values in your exams. So from exam perspective, it is good to remember these values. If you can't remember things, just play around the numbers. Now in this case, you have to play around 3, 4, 5 and find the least value like 3 by 5 as the thing with, each time the unit number you have to use. And you can find out the value of sin 37 degrees. And from then you can, you will kill it, I know that. So you have to just remember that one value, sin 37 degrees, and then it will become super easy, like how to remember these values. Similarly, you can play the trick for many other values of trigonometry. I'm talking specifically about these trigonometry values because these are new things that have been introduced in trigonometry and they are coming in exams even without, they giving up the numbers, like the exact numbers. Even sometimes they would give you the options in terms of root 3 or something when you're getting, 60 degrees. But when it is coming to 37 degrees and 53 degrees, they're just giving you the values and asking you right away for the answers. So many of us wouldn't be able to solve it. Even I missed a question once because I didn't remember the value of 37 degrees and 53 degrees. Now let's talk about something very interesting, for why we all have been studying, we all have been studying this, slope, and this vector, tan theta. Now we are going to talk about a problem, a very practical problem, and this is something that we would see in real life, especially if you're living in a slopey or hilly area. So this problem says there is a position A in space which is -1, -4. That is x coordinate is -1 and y coordinate is +4. The position of B in space is 3, 1. Okay, there is another position B in space that is 3, 1, where 3 is going to be the x coordinate and 1 is going to be y coordinate. When exclusively not stated or when explicitly not stated, then you will assume the normal way. Like first would be x and next would be y. And Tim stays at the position A and he commutes from A to B for daily exercise. So this person, Tim, is there who commutes every day from A to B for his daily exercise and he stays at the A position. Let's assume his home is at A and now he has to travel from A to B for daily exercise. And you need to find out the slope, find the slope of the path for his daily exercise and the distance he commutes. So to know whether this person is really, doing some exercise, we need to know whether this person is traveling up the hill or down the hill. So that we will come to know, that person is doing the exercise or not. So they have asked us to find out the slope of the path for his daily exercise and the distance he commutes. The total distance covered by that person, that means. Now, what are the options given to us? 37 degrees up the hill and 5 units, 53 degrees up the hill and 5 units. So 5 units is common. So we don't have to actually even worry about the distance. 5 units, 5 units, 5 units, 5 units. So it's something that I don't have to worry about. Now the issue is whether it's 37 degrees up the hill, 53 degrees up the hill, 37 degrees down the hill or 53 degrees down the hill. So they are being specific whether it is 37 degrees down the hill or up the hill or 53 degrees down the hill or up the hill. So they are talking about the inclination, the direction of the commute or the direction of travel. Now one simple way is do it in vector representation and get the answer. Sometimes you can just imagine these points and come to a conclusion. For an example, the position of A is -4, 1 and the position of B is 3, 1. So Tim has to travel from A to B. Okay. So put these points in your mind and think about it, how it goes. It's the simplest way of doing, finding out whether it is up the hill or down the hill. If you have some sort of upslope or downslope, if you have some sort of confusion, this is the easiest way to, do it. Like given only 2 points, this is the easiest way to do it. Now, think about these 2 points in your mind. And now you will think that, the person is staying at A, which is -1, 4 at a higher, height. And then he comes down to B, which is 3, 1, which means he's just traveling down the slope, down the hill. Okay, he's traveling from A to B, that means he's going to travel down the hill. Now what we need to do, like we need to find the exact theta. We know between these two, one is the answer. Like so it's basically down the slope, down the hill. So between C and D, one is the answer. So which one is going to be it? Which one is going to be it? One thing we can do is just subtract the thing, get the answer, or put the pen on the paper. Put the pen on the paper is the easiest way to do things. It's faster. It saves time. So one thing you can do is directly subtract the coordinates and get the answer. Just divide the y coordinate by x coordinate and finally state it, it's -37 degrees. And RA is equal to -I cap plus 4j cap. So the position vector of A. And RB is equal to 3I cap plus 1j cap. The person has to travel from A to B. A is the final point. So A would come over here. Okay. It's 4I cap minus 3j cap. Just a moment. So B is the final point. Correct. So B is the final point. Commutes from A to B. So the person has to travel to the point B. So B is the final point. So this person has to travel from A to B. So I was a little confused. I was thinking, I told you, right? Like A is the final point. By mistake, I told you like A is the final point. So I was a little confused. So B is the final point. So this is the final point. Now this person has to travel from A to B. So subtract B from, this is final, okay? This is final point. You have to subtract B from A to know about the slope, distance, or any other value. It's as simple as distance. You will get it even if you do A minus B. It's going to be opposite vector with opposite direction but with the same magnitude. But to find out the slope, we need to do B minus A. So that is going to be 3i cap plus 1j cap minus of 1i cap plus 4j cap. 4i cap minus 3j cap. Okay, 3 minus of minus 1 is going to be 4 and 1 minus of 4 is going to be minus 3. Now I know it is basically y by x, y component with all the sign by x. So it's minus 3 by 4. We just spoke as and when the value keeps increasing, it is 53 degrees. Then the value is lower around this 3 and 4 for tan theta. Let's say if it was 4 by 3, then it is 53 degrees. And if it is 3 by 4, it is 37 degrees. So it is minus 37 degrees. So the person is traveling down the slope. So it's a negative theta angle. So, if you see the quadrant, there are only two places in which direction or in whose direction you will travel up this slope. That is the first and second quadrant. Whereas in third and the fourth quadrant, you are descending, you are traveling down the slope. So it's theta is equal to negative, which means down the slope. So very arithmetic way of doing it, but the intuitive way of doing it is think about the height. Like how you think about, when an object is being dropped from a height. But that would work for, very less complicated coordinates. If you have multiple coordinates, the ball is traveling or the person is traveling, and finally you need to find out whether displacement is down the slope or up the slope, something like that. Then in those cases of complications, you may want to pull the vector, put it up, and you solve it faster than even using graph or, even using your mind sometimes. If your mind is fast enough, that's great. But just like me, if you're just like me, then that is a faster way of doing it. Just putting the vector and doing it is going to be very, very fast. Now we'll talk about an interesting problem on cardinal axis. Guys, cardinal axis is where you'll get your questions in exams. Mostly, distance and displacement is something, that is very obvious to public. You have been reading it from 8th class, 9th class and 10th class, and most of us might have learnt it in not the right way. Some of us might have learnt it as the shortest distance. Some of us might have learnt it about as distance having direction, but they haven't exactly told us what is this direction, how to find this direction. So now we know what is displacement, how to find the direction, what is the difference between different kind of even in distances and displacement. Difference between distance and displacement. And since we know this, we are not still going to get the problem on that. But this is going to make our life super easy. And you are mostly going to get your problem in cardinal axis. And in that cardinal axis, you might want to find the displacement or distance. And mostly it would be like distance plus displacement. When they are talking about distance plus displacement, our concept of displacement is going to help you a lot. Like the final point minus initial point is what you have to do along with the direction to find out the direction and the vector or the distance, or the displacement. Or the displacement. It becomes very easy. So in this case, a little sounds like many directions this person is traveling. Raghu is traveling 50 meters along east, 80 meters along north, 100 meters along west, and 300 meters along south, and 90 meters 45 degrees along northeast. So now comes the problem of drawing the graph. Now you draw the graph, it will create a huge problem for you, and even mentally you can't put this problem. Jotted in terms of vectors, problem is very easy. This problem would hardly take 2 minutes if you put it down in terms of vectors. If you understand this vectors in terms of cardinal axis, so east is plus I cap and north is plus j cap. So remember these two things, rest is intuitive. West is opposite to east and south is opposite to north. Now when this thing has become intuitive to you, it's super easy to solve the problem. So I'm going to say what is it going to be? First one is going to be plus 50 I cap. Now, the next one is going to be 80 J cap. And the third one is going to be minus 100 I cap. And in the south, it is going to be minus 300 J cap. And now talking about northeast at 45 degrees, you will have to resolve the components along I and J. Northeast is in the positive plus x plus y quadrant. And now what you have to do is you have to resolve the components in that quadrant to find the result. In this case, I think it is distance between the starting and the end point. So we are talking about distance between starting and end point. So it's basically displacement. Starting and the end point means it is displacement, nothing else. So now to do that, what are you going to do? You are going to put down the sign convention and then resolve the complicated one, the 90 meters travel one. So we just did this 50 meters towards east, 50 I cap, 80 meters towards north. That is going to be 80 J cap. Okay, this is 80 J cap, guys. This is 80. This is going to be 80 J cap. And 100 meters towards west is going to be minus 100 I cap, and 300 meters towards south is going to be minus 300 J cap. And 90 meters towards northeast, 45 degrees. Now this is where the complication of the problem lies. We are actually doing this problem to understand this complication of 90 degrees. 45 degrees, that 90 meter problem thing. So we need to do this. This is where the complication lies, right? Basically what it is, take the sine theta and cos theta like how we resolved before. You had a position, right? Even then, okay, this is magnitude. Then you had a position, but we still only needed the value of the magnitude. This 90 degrees is what, 90 meters is what we needed. 90 meters is what you needed to resolve it. The magnitude of the position vector or the distance between the positions in this case. So just resolve it along I cap and J cap. It's positive I cap, J cap. It's going to be, 90 sine 45 and 90 cos plus 90 cos 45 I cap plus 90 sine 45 J cap. Okay, 90 cos 45 I cap plus 90 sine 45 J cap. Sine 45 cos 45 equal under root 2, 1 by under root 2 So 90 under root 2, 90 by under root 2. So this is what you would get it. You add it to that, the huge sum that you found by using all of this. So guys, you need to correct this problem or assume that was 50 and then you'd finally get the answer. But you got the essence of the problem. That is the essence of the problem. Okay. So you have to resolve the components. The entire essence of taking up this problem was you should know if someone is talking about northeast 45 degrees. So these kind of problems have appeared in IIT JEE before. So they are talking about distance and displacement, but they are talking in terms of degrees, and degrees. So using those degrees, you will have to resolve things. This is how you will get the problems. They won't ask you a cakewalk problems when you're going to go to IIT JEE. Maybe JEE mains or even JEE advanced or even JEE mains. And even maybe in most of the competitive exams, they're not going to ask you a cakewalk problem. Maybe distance is something they would ask you, because in this case, still distance is a little confusing. I've been traveling 50 meters, 80 meters, 100 meters, now 300 meters and 90 meters. So it consumes a little bit of time. Those are the problems that are going to, absorb your time in the exam. Or sometimes it can be also, your time booster. But the thing is, they are going to ask you something around cardinal axis. Bodily direction is not something that they may probably ask, but they are going to ask you around cardinal axis. Now let's have a look at some interesting problem on distance and displacement. So let's say a car on a semicircular path with radius 2 meters from green to red point shown in the picture. Okay, what does it say? A car travels on a semicircular path with radius 2 meters. So this semicircular path this is the semicircular path. Say this is some sort of, the center of the circle. Then this is 2 meters. This is 2 meters. Okay, why we are getting into this? Okay, so the radius is 2 meters. Now we have to travel from the point green to point red, and then what has been asked is find the distance and displacement. Okay guys, what they have asked us is find the distance and displacement. Now what would you do? Let's just have a look at it. Just a graphics for you, okay? Now what would you do? Displacement is as simple as the distance between initial point and final point. Because in this case they have asked us the magnitude of displacement, I guess. Actually it should have been magnitude of displacement because the options are in terms of magnitude of displacement. But anyway, so it's 4 meters. It's just the diameter. And what about distance? Distance is going to be all along this circular path. You have to travel all along this because your car in this case was traveling all along the circular path. It does not matter which is the final and the initial point, but it has covered the journey along this semicircular path. So for semicircular path it is going to be pi r, whereas for circular path it was going to be 2 pi r. For semicircular path it's going to be half of it, it's going to be pi r. So pi r means 2 pi and 4 meters. So displacement should be 4 meters and distance should be 4 meters. No, displacement should be 4 meters. Only these two have 4 meters. And distance should be 2 pi, right? 2 pi. Okay, this is the one. 2 pi meters and displacement should be 4 meters. So it should be D. So guys, quickly skim always through the problem. I'm not skimming through the problem because we have more concepts to get into it. And whenever you skim through the problem, you got initially that this displacement is only 4 meters. Only these two can be the possible options. Among this is given to confuse you. 4 pi meter and 2 pi meter. You need to be careful to think about it. Like, you know, it is like not 2 pi r, it is pi r. You have to keep this in your mind. Now guys, what is this? This is something that you see every day, don't you? Like, be it in your bike, you're traveling with your father or mother, or be it you have your own private vehicle that you take from your uncle or something like that. You know, you have your vehicle or you see on a vehicle, you see this sort of, like something like this. What is it? It's a speedometer. Like even on the cabs, you would see there is a speedometer. Just what is speedometer showing me? Come on guys. Speedometer is showing me speed. That is measured in meters per second. Is it? No. Speedometer is showing me speed at that instant. Speedometer is exactly or trying to exactly measure the speed at that instant. So speedometer is talking about instantaneous speed. It's not talking about the speed itself. Speed changes from time to time. You must have noticed this meter is moving, here and there during the travel. May not be this, this much. That means your vehicle is going to, end up in a wreck or something. But it is traveling something, up and it's fluctuating all the time. So that's an instantaneous speed. When we are talking about instantaneous speed, it is about the speed shown on speedometer or the speed at that instant. When you measure that speed at that time, at that instant. And in other words, like in instantaneous speed, what you try to do is you try to approach that time. Like basically speed is distance by time, isn't it? Speed is distance by time, meters per second. So what you do is you try to approach that time as zero. Like you try to get into the time frame where it is like, very minimal. Let's say in some cases even 1 second. You'll measure what is that speed for that 1 second and call it instantaneous speed. But it is going to change from second to second or something like that. Okay. So while finding out the instantaneous speed, the time has to tend to the delta time. That means change in time has to go to zero. Assuming that it's a very small time, we'll find out instantaneous speed for every such small time. Okay. And now the thing about instantaneous speed is, it's an ideal thing. It's not the most practical thing. You must have heard about, like instantaneous speed. Speedometer is showing me this, speedometer is showing me that. But still, can you realistically, achieve the target? There are many things that will come in the way. Like instantaneous speed is not talking about, traffic sometimes. Instantaneous speed is not talking about changes or fluctuations speed. So instantaneous speed does not exactly give me a practical measurement. I'm just trying to, keep up to the target, keep up to the prediction to reach a destination. So that's about instantaneous speed. So instantaneous speed is a speed at an instant where time delta t tends to 0. Okay, guys. And now we'll look at average speed. Average speed is more of a practical time. Sometimes this is what like Google Maps is showing you. You need to travel with this much speed on this route, or you are probably going to take this much time to reach that kind of destination. So they have already assessed the average speed, because it is going to include every such factors. Even sometimes the direction of wind, the traffic, the current scenario, the current honking, everything in that place. And because what you're going to do is you're finally going to measure the outputs, and from that you're going to derive the results. So it's basically average speed is total distance by total time, ratio of total distance by time. Okay, guys. So let's say if I have to travel to, let's say Mumbai to Chennai, or Chennai to Hyderabad, or Hyderabad to Delhi, what am I going to look at? Instantaneous speed or average speed? I need to look at average speed. I need to make sure I maintain a speed above average speed, if that limit is permitted in my given target. So, but the thing is, I need to make sure that I stay above average speed, or I make some, like models around it. Like I'm going to stop for this many hours, and I will plan accordingly if I have the average speed as the, the input to me or the result. So it's basically more of a practical thing. It's not an ideal thing like instantaneous speed, which only helps us model and predict, but may not be the ideal thing to do. And basically, total distance by total time, that is how you define it. Average speed is total distance by total time. So you'll add each individual distances on the path and divide it by total time. So this is like, again, like very, like physics thing, but you'll add total such distances and divide it by time. You won't take displacement and talk about total distance by total time. Okay. Now we have been talking about, all this instantaneous speed. Now we need to get into something known as vector, because vector is something very important in kinematics. So what is instantaneous velocity? Similar to, instantaneous speed, but attached with a direction. But the thing about instantaneous speed is, instantaneous velocity is, The thing about instantaneous velocity is, the direction matters a lot. For example, in this case, the object is moving in a circular path. Okay, let's assume this object, green color object, is moving in circular path. Then what is happening? The velocity is changing. The instantaneous velocity is changing from time to time. So the velocity you're measuring at the tangent is instantaneous velocity. So throughout this path, the velocity is changing. And then each velocity along the tangent is called instantaneous velocity. Okay, so instantaneous velocity is the velocity measured at an instant where delta t is going to tend to 0. Just like how we did in instantaneous speed. And instead of, distance, we would take the delta direction, that small change in direction. If it is going to be along, like a circular path, the delta displacement would matter. Like it would tell me exactly the direction. Still, there is a difference between delta S, or the delta, displacement, and delta distance. Or else what you can do is, if you have something that can measure velocity, you can simply make use of this. What you can do is, you can simply make use of the thing where time is tending to 0 and you measure the velocity. For every small time, you are just measuring the velocity. But again, instantaneous velocity is many times an ideal method. In some cases, it makes sense, but in many cases it will become very ideal method. So we'll again go for average velocity. So guys, what is the difference between average velocity and average speed? In average speed, we were specifically talking about the total path, the total length covered in a path or the total distance covered. But in average velocity, you are not worried about anything other than the distance between initial and final points, or rather the final and the initial points. So you're basically worried about displacement. There is no such thing as total displacement, right? Like total final displacement is something that is there. But when you're talking about displacement, what you're going to do is you're simply going to take, I've written it down as total displacement. This is some mistake that we would make all the time. So when we are talking about average velocity, we are not concerned about, the distance or total path or something. We are only concerned about exclusively about displacement. So the distance between initial and final point, or the final and the initial point in a given time. So you divide it by the total time. For the time, it's a scalar. You'll keep adding it. If it takes 1 hour, it's 1 hour. But it is going to be a result of practical output, for a displacement. Let's say I want to travel from point A to point B, given that is the shortest path to reach between two destinations where that person is not stopping in any other destinations or do not have any work at any other destinations. Then what you do is simply find out this direction and this displacement, the shortest distance or the shortest length, and divide it by the total time. And it is also sort of a practical output. Let's say you have to travel by an helicopter or a drone, then you will make use of basically displacement. Still not again displacement, that I know, but still you can do it using you can predict it using displacement rather than distance. Now these things being said, we'll do a problem around this. We'll do some interesting problem around this. Okay. Let's say we have a situation where the car was traveling at speed S1, T1, S2 for time T2, S3 for time T3, and so on till Sn for time T1. So basically there is this car which is jumping crazy, but it is traveling along x-axis direction. That's what we are talking about 1D kinematics until now. Even though we have been talking about vectors to understand slope and everything, I wanted to give you an exposure to vectors, the application of vectors, why vectors are important to understand it. Many concepts in distance, displacement and other areas. But the thing is, let's say there is this humpy-jumpy car traveling only along x-axis, and at speed S1 for time T1 and speed S2 for time T2 and speed S3 for time T3 and so on till speed Sn for time T. And so many speeds at so many different times or so many different time intervals rather. So it's speed S1, S2, S3, so on till Sn, and the time is also going to be T1, T2, T3, so on till Tn. So then find the average speed. Guys, many of us would get tempted to add the speed and divide it by time, because this is something that has been built in our mind. We have been built in our mind that whenever we are going to talk about average, we have to take an arithmetic average. Just add the speed, take the average of the time. But what you have to do is you have to ignore it. You have to go by the physics. It has been asking you for the average speed. That means the practical instantaneous speed above which you have to travel so that you will get to the destination. So that being said, what you'll do, you'll first find out the distances, the individual distances for the individual time intervals, and add them and divide it by the total time. It's really that simple. Okay? Let's see what has been written. Is there a solution? Yeah, I guess so. Yeah. So there is speed S1, S2, S3 and Sn, and time T1, T2, T3 and so on till Tn. So what is the total distance going to be? I will have to multiply that individual speeds into individual time intervals, and so on. I will have to keep on doing it, and so on up until Tn. And I will have to calculate total time. That is easiest doing it as T1 plus T2, so on till Tn. Now what you are going to do is, for this average speed, you will find out all these distances, and you'll add this total distance S1 T1, that is what is written over here, S2 T2, S3 T3, S4 T4, so on till Sn Tn. How many ever n's they give, or even if they don't give you any definite number, if they give you n's, then this is going to be how you do it. T1 plus T2, T3 plus T4, so on till T7, Tn. It should have been Tn. Okay. Now we understood very well, given different, like speeds for different time intervals, we should not divide the speed by time, like adding just the speed by time, which is our, natural intuition of going towards it. We have to use a physical intuition or physics to understand things. We have to find out individual distance, small distances and divide it by time. Now that being said, we'll have a look at an interesting problem, which will, again differentiate between speed and velocity. So car travels, again, you must have had a look at the problem in the earlier, video, in the earlier part of the video. The car is traveling on a semicircular path with radius 4 meters. Just make use of something like yellow marker. Car travels on a semicircular path with radius 4 meters from green to red point shown in the picture within 10 seconds. Now, what is it saying? A car is traveling on a semicircular path, the same path that we saw earlier, with a radius 4 meters. So this time the radius is 4 meters. I guess earlier it was 2 meters. From green to red point shown in the picture. So it is going to travel from this green to red point, the same thing. But what is the extra thing given over here? Within 10 seconds. So this commutation or this journey has been completed within 10 seconds. I mean, like in this case, it might not be necessarily like a commutation, something it's traveling on this curved path. So it has completed it within 10 seconds. So now what we need to do? We need to find the speed and the velocity. So this is a problem that is going to clearly talk about speed and velocities. This is one of the top-notch confusing ways, guys. Like this is the way that, like examinations will try to confuse you. Like they will suddenly pull out your concepts. They will ask you for a circular path. And it wouldn't be even related to a circular path motion. It would be basically related to a simple, average speed, average velocity problem. So you need to just keep on building this basics, like building blocks, so that, you don't slip out in either like ways, Now, this car has traveled. Now the thing is, it's 4 meters radius. Let's skim through the problem quickly, guys. So it's 4 meters and within 10 seconds. So radius is 4 meters means the displacement is 8 meters because it's going to be the diameter. And within 10 seconds means 0.8 meters per second. Okay? 0.8 meters per second. I guess only one option is over there. But let's even see how to calculate speed. Speed is going to be total distance, this distance, and that being said, this distance is 4 pi r. Sorry, 4 pi. It's basically only pi r. It's going to be 4 pi. And divided by 10 seconds, which is going to be 0.4 meters per second. So it's option B. Okay. Now guys, these are some things you should not do when it comes to speed, average speed. When we are talking about average speed, don't try to add speeds. When we are talking about average velocities, this is don'ts. This is to, program your mind or, tell you again and again so that you don't forget it. Average speeds, you should not add speeds. These are all not symbols and this is a don't. So don't do it. The objective is the following relationships are wrong. You should not do it. So average velocity, you don't try to add velocity. Average speed, you don't try to add speed. You don't try to equate average speed and average velocity. You never ever will try to equate average speed and instantaneous speed. They are very different things, guys. And similarly for average velocity and instantaneous velocity. And remember, if someone told you tan A is equal to tan B, does not necessarily mean A is equal to B. At least as far as physics is concerned or even mathematics is concerned, it is not true that always if tan A is equal to tan B, then tan A is equal to B. You need to remember this. The entire slope will change. That means the entire perception of us is going to change. Okay? Now guys, we talked in the last class, like I will tell you at the end of the next lecture, like how to propose the theory, some laws for physics, guys, some laws for physics. So now the thing is, how to propose a theory. So this proposing a theory is not, like a very complicated approach or like a very complicated thing to do. Actually, most of us can propose theory given we know the approach, we know how to do it. So it is really as simple as that. Proposing a theory is not a very complicated thing. So as how to propose the theory, let's take an example. So let's say you are the Newton sitting under the tree or working in your farm and observe that apple is falling down. You thought that the apple is falling down. You went and said to people, hey, this apple is falling down, apple is falling down. There is some force pulling it. I'm pulling you just like that. Some force is pulling, objects down. People don't believe you. People ask you like what you're talking about. And you need to prove them that this works. And how did you start it all? You started by seeing the apple falling down. Still there can be very few things that will just come from mind. But most of the things will come from observations. So to propose a theory, you have to observe something unique. So this is the first thing, guys. You observe something unique other than, like better than other people or something, that other people did not observe. Note it down, guys. Note it down. Record it. So you need to observe something. You need to observe something unique. But also you need to systematically note it down and observe it. You need to conduct this observation again and again. It should not be, like something that you observed once, just because there was some phenomena at that specific place. But it has to be applicable for wider range, wider places or like wider scenarios rather. So now the thing is, you observed apple fell down. You observed it. Awesome. Now you try to do it again. You'll again observe the same thing. If you again observe the same thing, note it down. Even if not note it down, you observe something unique, then there is something, like there is going on, like there is something happening, that phenomena, that natural phenomena that people didn't understand. So you will have to note it down. You have to observe it and note it down. The systematic observations itself can help your theory get out, help your observations get out, help your unique, that thing you have come across to get out. Now the thing is, once you observe this, the next thing would be you have to control the experiments. Okay. So this Apple-Newton case is something that might happen everywhere, like, any place on the earth. But there are many things that won't happen everywhere. You need particular medium, particular material to conduct the experiment. So now that being said, maybe your experiment is not valid in every condition. What does this control experiment mean is, your experiment is not valid in every condition. You may want to control the experiments. You may want to create a controlled environment. Okay. So let's say now we'll take a, like an hypothetical or whatever you call it, like kind of an ideal situation where you found that apple fell down. You wanted to go and say people, but you started recording it because people won't believe it. So what it is, now you started recording things. Now you may want to conduct the experiment again. Now you thought you will go between some two planets that are equal masses, that are already in equilibrium, and conduct this experiment between them. Then there will be an issue, guys. It won't happen because gravitation is not actually the force between Earth and a body on Earth, or Earth pulling a body. Basically, gravitation is attraction between two masses, or the forces between two masses. Okay, gravitation or gravitational force is more aptly about attraction between or forces between two masses. Keep this in your mind. You have been reading since your childhood on newspapers or something like the articles that gravitation is attraction between like a body on Earth. But gravitation, to be more aptly said, is attraction between two masses. Okay. Now you may want to test your observations for different experiments. That is something that you may want to do. Let's say you are dropping it from different heights, maybe to find out Newton's equation of motion, or some new derivative of Newton's equation of motion, or something unique other than Newton's equation of motion. You are proposing something like, magnetic unipole, something like that. Just like we have, like electron, protons, you're trying to produce, propose something like that. Now you are going to test your hypothesis or, the observations. Sometimes it can also, the scientific method also can start from hypothesis. But now in this case, you have observed something. Now you are going to conduct some controlled experiments, and you're going to test your hypothesis using these controlled experiments. Okay, now this is called controlled experiments. Now the next thing would be, you have to reason it, you have to qualitatively and quantitatively reason it. So what do I mean by qualitative and quantitative? Okay, qualitative means that is understandable by majority of the people or to a layman. So if you're the first one who came up with the gravity, so let's say you want people to understand it and you came up with gravity, you cannot state things quantitatively. Many of us will get confused. You come to me and say, hey, I dropped this thing, I observed 1 meters per second acceleration or 9.8 meters per second acceleration, per second square acceleration. So that wouldn't sound very logical to me. I would be like, what are you talking about? Then you tell me, no, I dropped it from so-and-so height and then it came down so-and-so time. I still won't understand it. Then you said this and then you say that, what? I have a reason for it. Because Earth is pulling you down. Now I would be like, what? Earth is pulling me down. Then you drop your phone. Then you drop your phone and see whether it is happening. Or like something like, in those days it might have been an apple or something. Then you show people, hey, this is dropping down. Just like buoyancy force. Then Archimedes observed buoyancy force. People initially thought, this person has gone mad. He's a brilliant person, but he has gone mad. What is he doing? But the thing was, he was initially not able to give that qualitative reasoning. Qualitative reasoning to people, to as much as to understand him. But finally, he won the game. But now the thing is, you have reasoned your observations and record. You have observed it. Now you need to conceptualize it and see the math around it. What I mean by quantitative means you need to see the math around it, and conceptualize means qualitative. Like let's say I found out that when I take two unlike charges, they attract. That is conceptualization. Then I applied, observed it. Then I applied under different conditions where there aren't any positive or negative charges. That that will apply more force, and then I will conceptualize it. I will say people that unlike charges attract and like charges repel, and I will work on a math around it. Okay, I'll develop a math around it, and then I will take it forward to the scientific community, because scientific community will believe in numbers, and majority of the people will also believe in numbers once they understand the concept, because the concept again will start going in the reverse direction. So you need to give the quantitative reasoning. You need to show them the math. Now the steps involved in quantitative and qualitative reasoning is understand the logic first. So you have observed something, you have conducted the experiments, you need to understand the logic first before you make the logic understandable or comprehensible to other people. And then you need to also present the logic. You need to present the logic really well. To propose a theory, you need to present the logic really, really well and work it out for different numbers. Okay, which will give some quantitative reasoning, which will give some believable results, which will tell me, this would work. Okay, it's really as simple as that. Now we have done all of this, like quantitative reasoning, qualitative reasoning, etc., etc., etc. Now we are going to come to the important part. That is, the important part is mathematical modeling. So guys, Galileo observed gravity before Newton. Galileo said that if you drop a mass, like two same masses from height, they will come down. They will come down at the same speed. They are pulled by the same acceleration, irrespective of their masses. But why Newton's theory was more accepted? Politics apart, why Newton's theory was more accepted? Because he wrote down the entire equations around them. I don't know whether he got it from anywhere, but he wrote down so many equations, so many equations, so many mathematical models around just gravity. So it ultimately made sense to us when we put numbers in those formulae or in those mathematical models. So we eventually started admitting, okay, what this guy is saying is correct. It makes sense. I can make use of this. If I know this is the gravity, I know I should not drop a ball from this height or something. I should, hit the ball so much so that it crosses the boundary. So people started understanding this mathematical model. Math started becoming the king. So that is how, you have to develop a mathematical model around your logic, else people won't comprehend it. People won't simply comprehend telling them that, gravity is pulling it down. People may see it, people may believe it, people may even give you a name. But at the end of the day, the credits will be pulled out by the person who develops the mathematical model in most of the cases. Even for an example, I'll come to that later. Anyway, develop the math around your logic. Let's say now you have to work it out every time. Okay. Now you have to work it every time. Then you have to develop a mathematical model. It's not possible that you gain recognition without a mathematical model. Try to work on the numbers, like try to put like substitute values and in the numbers, and also develop the mathematical model, or develop the mathematical models and put in the numbers. Accompany with necessary conditions. Sometimes there are some conditions under which only it works. And publish it in some or the other form. Be the first one to publish it. The reason being, I'll tell you a small story. Henry Cavendish and Coulomb came up with the same kind of electromagnetic force theory. But Coulomb was more successful. Both of them made the mathematical model. Both of them did everything. Both of them understood electromagnetic force. Both of them did A to Z of it. Henry Cavendish made it before, but Coulomb was more successful. The reason is very simple. Coulomb published it first. It's the other thing, what has Coulomb done apart from that? But Coulomb is the one to first publish it. Even though Henry Cavendish is an equally reputable scientist, but he did not publish it. So the law itself became Coulomb's law. It is really as simple as that. So publish it. Like, you understand that mathematical model, share the knowledge with people. Share the knowledge with people, but not privately, but more of like, on something that is more scientifically acceptable, or that is more visible to more people. That is very, very important when you are developing a mathematical model. So you must be the first one to do it, right? You must be the first one to develop that mathematical model. So now the thing is, you have developed the mathematical model, you have to predict it and keep predicting things. You will keep predicting, okay, I'll go to moon, this is going to be the gravity, since the mass of the moon is this much. The gravity on the earth was 9.8 meters per second. Bravo, I see this apple coming down in 1 second. Now I go to moon, the gravity is lower, the mass is lower. It is going to take 1.5 seconds to come down from the same tree. You keep predicting it for different numbers. It is very important that you use your math and logic to predict things. And that is why you are developing the model. That is why you are developing the qualitative reasoning. You keep predicting things. You may want to exploit it. You remember, you may want to exploit the theories that you develop for humanity. That's the goal of science. Now, you have to show it off in front of people that your prediction works. Else they won't believe it. Okay? You'll have to show it off in front of people that it works. Else people won't believe it. Now, that being said, you will have to verify whether it works or it does not work. Many a times, guys, people come up with theories. People will come up with theories from an hypothesis or even from observations, then with controlled experimentation. They will be all the way until the end. But fortunately and unfortunately, it won't work. The issue is, there would be some small things that they might have not noticed, that the theory may not work, but they'll keep on refining it to make it better for different things. Maybe it is only applicable for particular media. Then you start predicting, okay, this is my controlled experiment. So you'll keep verifying it and falsifying it, whether this theory is true. If I say this, if I'm going to throw a ball up and it's going to always travel up, because even on the upward direction there is a earth, because I'm standing in the core of the earth. It does not make sense. So I will have to verify it, whether it is going to go up and stay over there. So this is where most of your success will lie. Now the thing is, the ball is in your court. You have to show the practical applications and make it a reality. This is more important. This would not be given in your book anywhere. But this is very much important when you're talking about scientific methods. It's actually a topic in your, JEE mains, guys. JEE mains, and also sometimes in your board exams. So the thing is, when, you want to find the most success in your life, your theory should be utilizable. If your theory is, not utilizable, if it stays only on paper and people don't care about it, people will never come to know about it. Because not everyone is interested in science, not everyone is interested specifically in that subject or in that field, or not specifically going into that thing. So people will not understand. You have to bring out the practical applications, you have to make it the reality, you have to show it works, you have to verify it. And the thing is, Verify your predictions again with experiments and keep publishing it. So the key is publish it. If you have found something, just don't discuss with only very few people. When you have made a scientific method, or if you have discovered something, just keep talking to people, and don't go with few people or one person. Just keep on discussing it with people, and thus your theory will be verified or falsified as well when it goes into the public. That is as simple as it is. Now guys, this is actually a scientific method, a topic in your syllabus. Now, it's a method. So what's a scientific method? A scientific method is a method to study the natural phenomena, because science is about nature. Science is about the observations in the nature, be it biology or be it, like physics or be it anything. It's an observation in the nature. And how do you approach the science? Or to propose any theories, scientific method, or to propose any theory, you need to know a few things. That is, first you need to do systematic observations, and then you do controlled experimentations, and then you give qualitative and quantitative reasoning around it. You have to justify things using qualitative and quantitative reasoning. You have to validate your hypothesis. You have to give people the understanding, and then you develop mathematical model to predict things, and you'll have to finally verify or falsify things. I'll come back again. So first, you'll observe things. The apple fell down, you observe the apple. The second thing what you have to do is, you have to conduct experiments, controlled experiments around them. Let's say the example of electron and proton being attracted, or something, like positive and negative charge being attracted. You need to remember the positive and negative charge thing as the next thing. You'll remember it. Okay, systematic observation means you need to observe it again and again and again and again. The systematic observation should be there. There should be controlled experiments. Then you need to make people understand it. So first, you yourself have to do things to understand and interpret it. So that is going to be systematic observations and recording things and controlled experiments. Then you know that you have found something unique. Now what you need to do is, you need to give the qualitative and quantitative reasoning around it and develop a mathematical model so that the scientific community is able to understand it and they're able to predict things, and you are also able to predict things. And then using those predictions, you need to, using those mathematical models, you need to make predictions. Then your theory has to be either falsified or verified. Or rather, let's keep it on the positive note. It can be verified. So systematic observations is the first thing. Then controlled experiments come. Next comes qualitative and quantitative reasoning. Then comes mathematical model. Then comes prediction. Then comes verification or falsification. And you are the next Newton. And guys, very much important thing. Don't be afraid of failures. Don't be afraid to try new things. You should keep on trying. Beat your exams. Beat proposing something. Beat some idea in your mind. Don't give up on it. Keep trying. Keep trying. Keep trying. Exams come and go. It does not matter, but keep trying. If you did not face failure, then probably it is that you are not going to face success. And guys, thank you so much. Thank you to everyone who has been following all this channel. Haraz, Mosam, there are Sri Chowdhury, so many people. Thank you for being regular on the class. Stay tuned. Keep learning, keep learning, keep learning, keep learning. Keep learning and keep sharing this knowledge with as many people as possible. I hope you loved this lecture. And guys, this is a very important, philosophical quote from the greatest philosopher across the world. Ego, kill it. Love, value it. You have to value the love. You have to keep the love, to value it. You need to keep it safe. Smile, keep it on your face. Always keep smiling. Beat any situation, beat anything. Keep smiling. Forget this sorrowness. Keep happiness. And gossips, just ignore them. Don't, encourage gossips. Just, don't encourage your mind to listen to gossips or to gossip. And success, guys, you have to achieve it. You have to work hard for it. For achieving, you need to work hard for it. You need to, keep the timing right on the test and learn concepts time to time. Don't memorize things. You need to work hard. You need to, tune yourself to get to there. Not necessarily, but you need to tune yourself. If you understand concepts, even if if someone memorizes and cracks the exam, let's say, if you know the concepts and you crack the exam, not maybe better than the other person, but still you are far ahead. Someday, you can excel in things and you will keep moving. You slowly understand the society and you'll keep moving. It's not a big deal. So success, you have to work hard to achieve it. And knowledge, guys, acquire it is the biggest wealth, and share it, guys. Share it with your friends. Brainstorm the concept with your friends. Brainstorm the concept with your friends. That is more important. Brainstorm about this lecture. Ask them what do they think about it. And guys, if you have any doubts, to comment on the box below. And guys, keep learning and keep sharing. Keep sharing and keep brainstorming. That is also very important. And love physics. No matter what, love physics, love mathematics, love chemistry, love all of them. All are very important, especially if you're preparing for engineering. And if you're preparing for something like medical, keep loving medical as well. I mean biology. But love physics more. And guys, if you want to get some free live classes, go on to Unacademy app and download it. You can get it on Play Store or App Store. And guys, if you're serious about preparing for test, you can go for like our IIT JEE package and get this subscription, our premium subscription, where you will have access to structured learning, live quizzes, and all this exam pattern based tests, and even live tests where you're assessed in real time, and many reputed people on the platform who will be taking the live classes and doubt clearing sessions. And guys, make use of this coupon. You know what to do when you're in 10th, 9th or something, or if you're long term or a dropout, or if you're stuck in a lockdown. And take care, guys. Stay safe. Take care. I hope you enjoyed the lecture. Comment on the box below. Share it. Like it. Share it. Keep sharing it. That is very much more important. And subscribe to our channel. Stay tuned. Stay tuned to each lecture. Grasp the concept. Keep grasping the concept. Alright, guys. Take care. See you in the next lecture.